Hello everyone, welcome to the next lecture. In this lecture, we are going to solve some problems based on the concept that we studied previously. Okay, the first question we have over here is the total charge entering a terminal is given by Q is equal to 5t sine 4 pi t millicoulombs. Calculate the current at t is equal to 0.5 seconds. Okay, so as we know that current I is equal to d by dt of your Q, rate of change of your charge. So we know that Q is given over here to be 5t sine 4 pi t millicoulombs, okay, which is equal to, so I becomes equal to d by dt of your 5t sine 4 pi t, okay. So we know that d by dt of your A into B is equal to A differential of your D, okay, plus B d by dt of your A, okay. So it means that it will become like 5 is common over here. We are getting T, differential of sine 4 pi t is your cos 4 pi t into 4 pi plus sine 4 pi t differential of your d by dt of t, which is equal to 1, okay, at t is equal to 0.5 seconds, okay. So it will be equal to 5 into, after substituting the values of t in the equation, we are getting 0.5 cos 2 pi into 4 pi plus sine 2 pi into 1, okay. So after solving this, we are getting 5 is equal to 2 pi plus 0, okay, which is equal to 10 pi, and if you put the value, so that becomes equal to your 31.42, okay. Since it is clearly mentioned the charge is in millicoulomb, it means that we are getting the value in milliamperes, so it is equal to 31.42 milliamperes, okay. Another problem. So in the second question, it is clearly given like determine the total charge, okay, entering a terminal between t is equal to 1 second and t is equal to 2 seconds if the current passing through the terminal is I is equal to 3t square minus t amperes, okay. So we know that one thing very clearly, like Q is equal to integration of I into dt. So integration of current is your charge, okay. So it means that after substituting the value of current in the equation, we are getting from 1 second to 2 seconds, okay, it is 3t square minus t into dt, okay. After solving this problem, we are getting 3t cube upon 3, okay, from 1 to 2 minus t square by 2 from the, after substituting the limits, okay. So we are getting 8 minus 2 minus 1 minus 1 upon 2, okay. So that comes out to be 5.5 coulombs, okay. So let's solve the third problem, okay. So it is given like find the power delivered to an element at t is equal to 3 milliseconds if the current entering its positive terminal, okay, I is equal to 5 cos 60 pi t amperes, and the voltage is A is equal to first part of the problem is V is equal to 3I, and this in the second part it is given like voltage is equal to V is equal to 3 di by dt, okay. So let's solve this particular problem. Let's solve the first part, okay. Let's solve the first part of the problem. So as we know that P is equal to, power is equal to voltage into current, okay. So in the question it is clearly mentioned that voltage is equal to 3 times of I, okay. So if we substitute the value of V, we are getting P is equal to 3I square, okay. So that comes out to be your 3, after substituting the values of current, we are getting 3 into 25 cos square 60 pi t. Okay, so time is given to be 3 milliseconds. Okay, so we can say it like 75 cos square, so it comes out to 60 pi 3 upon 1000. Okay, so it comes out to be 75 cos square 0.18 pi. Okay, so after solving this, we are getting the power to be equal to 53.48 watts. Okay, so you can check the value of cos 0.18 pi and you will get this particular solution. Okay, so in the second part of the problem, like it is mentioned that V is equal to 3 times of di by dt. Okay, so it means that, like, let's substitute the value of I in the problem. So 3 d dt of your 5 cos 60 pi t. Okay, so it is coming out to be 15 into 60 pi your minus sine 60 pi t. Okay, so it is coming out to be 900 pi minus 900 pi sine 60 pi t. Okay, so P will be equal to, power will be equal to V into I. So it will be equal to your minus 900 pi sine 60 pi t into your 5 cos 60 pi t. Okay, for t is equal to 3 millisecond. Okay, so after solving the equation, okay, so we are getting minus 4500 pi. After substituting the value of t in the equation, we are getting sine 0.18 pi into cos 0.18 pi. Okay, so after solving this, we are getting the power to be equal to minus of 6.396 kilowatts. Okay, so we are getting value of minus 6.396 kilowatt. Okay, so let's start with the fourth problem. Okay, so calculate the power supplied or absorbed by each element in the figure. Okay, so we have a total of 4 elements that we are given in the figure, and we need to identify which of the element is supplying power and which of the element is delivering your power. Okay, so let's start the problem. Okay, so as you can see in the voltage source, okay, the current is leaving the positive terminal of the battery. So it means that P1 is equal to, so as we know that power is equal to the product of voltage and current. Okay, so voltage over here given is 20 volts, and the current that is leaving the positive terminal of the battery is, since it is leaving, so it can be represented by a negative sign. Okay, so since the current is leaving the positive terminal of the battery, so we can say that this particular element is delivering power. Okay, in the second element P2, the current is entering the positive terminal of the battery. So it means that the element P2 is basically absorbing power, which is equal to plus 60 watts. Okay, the next element, the third element we have. So in case of P3, it is clearly, we can clearly see the current of 6 amperes is clearly entering the positive terminal of this particular element. Okay, so this element also, it is also absorbing your power. That is the value of that particular power that is absorbed by the element will be equal to plus 48 watts. Okay, the element P4 over here. Okay, so element P4 over here. So in this case also, this is the positive and this is the negative terminal, and as you can see, the current So the current, basically the current of 0.2 I, which means 0.2 into your 5, which is equal to your 1 ampere, is basically flowing from the negative terminal to the positive terminal of the positive terminal. Okay, so it means that this particular dependent current source also is delivering power. Okay, so how much power it is delivering? It is equal to 8 into the current which is flowing in this particular branch, which is equal to minus 1 ampere. So it is equal to minus 8 watts. Okay, so like the element 2 and the element 3 are basically absorbing power, and the element 1 and the element 4 are your delivering power. Okay, so they are delivering power. Okay, one more thing that you need to remember, if we add all the powers, okay, that are absorbed and the supplied, P1 plus P2 plus P3 plus P4, okay, so we are getting what? We are getting, it will be equal to minus 100 plus 60 plus 48 minus 8, which is coming out to be your 0. So P2 plus P3 is coming out to be P1 plus P4. Okay, so that's all for today, guys. In the next lecture we will solve some more problems on the basics of network theory. Okay, thank you.